Time is going to pass you by, no matter what you get to create and what you're doing in the time you have. I want you to feel inspired and empowered to get in intentionally about how you are spending your time. Because how you spend your time is what your life is all about. Thank you so much for pulling all your time to listen to something that could actually help you to improve your study skills. So today's topic is congruence relations, and this is from group theory, and this is related to MFCS, DMS, DMGT, and also for the BSc students. See here, two problems are flashing on the screen. Those are: show that the set 0, 1, 2, 3, 4, 5, 6 form an abelian group with respect to addition modulo 7. And next one, we have to prove that the set G is equal to 1, 2, 3, 4, 5, 6 is again an abelian group with respect to multiplication modulo 7. Here the set is given and we have to show that the set is an abelian group with respect to the binary operator, that is multiplication modulo 7, here addition modulo 7. So what is this congruence relation? And let me explain you what is this congruence relation. Congruence relation is nothing but let a comma b comma m be three integers. If m divides, see here, among these three, if m divides a minus b, then we can write it as a congruent to b mod m. See, very clear? So, if a, b and m are the three integers, if m divides a minus b, then we can write as a congruent to b mod m. The set of integers modulo m. See here, if you take any set, the set is defined as im is equal to 0, 1, 2, 3 and so on m minus 1. Then the operation addition modulo m, that is defined as the remainder when a plus b is divided by m. So addition modulo m is nothing but the remainder when a plus b is divided by m. And next one, the operation multiplication modulo m, that is xm, is defined as, see here, a xm b is equal to the remainder when a into b is divided by m. So we want only the remainder when a into b is divided by m. So these two are the addition modulo m and the multiplication modulo m. So coming to the congruence relation, so this is nothing but when we have three integers a, b and m. When m is divided by a minus b, this can be written as a congruent to b mod m. And coming to the addition modulo m, that is a addition modulo m b is nothing but the remainder when a plus b is divided by m. And coming to the multiplication modulo m, which is nothing but the remainder when a into b is divided by m. So these two are the addition modulo m and the multiplication modulo m. And let's get started to solve this. So now the binary operator here is addition modulo m here, and here is the multiplication modulo m. See here, the first question here is show that the set 0, 1, 2, 3, 4, 5, 6. See here the set value is given and we have to show that it's an abelian group with respect to the binary operator, that is addition modulo m. So now I am using the composition table. So using the composition table, I'll prove all the 5 properties. In order to show it's an abelian group, we need to show it's a closure, associativity, identity, inverse and commutative law. If all the 5 properties holds, then we say that the given set is an abelian group. And let's get started with this composition table. So how to fill this composition table? So it's so easy that, so 0 plus 0 is 0, clear? So 0 plus 1, 1, 0 plus 2, 2, 0 plus 3 is 3, 0 plus 4 is 4, 0 plus 5 is 5, and see here 0 plus 6, value is equal to 6. Clear? All are done here. And next one, here 1 plus 0 is 1. So 1 plus 1 is 1, 1 plus 2 is 2, and 1 plus 3. See here, 1 plus 1 is 2 here, and 1 plus 2 is 3, and 1 plus 3 is 4, and 1 plus 4 is 5, and 1 plus 6. 1 plus 5 is 6, and 1 plus 6 is 7. So here there is, see, among these only 6 elements are there, and therefore, so we addition modulo m is nothing but the remainder when a plus b and 1 plus 6 is divided by, see here, m. So what is m here? When it is divided by 6, 6 ones are 6, and the remainder here is 1. Sorry, this is addition modulo 7. See here, we have to divide with the 7. So if I divide with 7, 1 will be the answer. 7 ones are 7, and 0 is the remainder, and we have to write 0 here. Clear? And next one, 2 plus 0. So after adding 2 plus 0, so we have to divide with 7, so 2 will be the remainder. So this is 3, and this value is 4, and this value is 5, and this is 2 into 4, this one is a 6, and this one is 2 plus 5, this is a 7. When 7 divided by 7, 7 ones are 7, and the remainder is 0. And if you go with this 8, so 8, so if you take 8, the remainder 1, it is divided by 7. So this is a 7 ones are 7, and the remainder here is 1. Clear? And next one, 3 plus 0 is 3, and 3 plus 1 is 4, and 3 plus 2, this is 5. 3 plus 3, this one is 6, and 3 plus 7, this is 7. 7, when divided by 7, the remainder is, see here, the remainder here is 0, and 3 plus 5, 8. 8 when divided by 7, the remainder is 1, and 3 plus 6, 9. So 9 when divided by 7, see here, the remainder value is 2. Clear? And the next one is 4 plus 0 is 4, and 4 when divided by 7, the remainder here is 7. And next one, 4 plus 1, this is 5, and 4 plus 2, this value is 6. And next one is 4 plus 7. 7 when divided by 7, the remainder is 0. And next one is 4 plus 4, this is 8. 8 when divided by 7, the remainder value is 1. And next one, 4 plus 5, 9. 9 when divided by 7, the remainder here is 2. And next one is 4 plus 6, which is equal to 10 when divided by 7. The remainder here is 3. So put 3 here. This is 5 plus 0 value is 5. 5 plus 1, 6. This is 5 plus 2, 7. The remainder is 0. And next one, 5 plus 3, 8. The remainder value is 1. And 9. For 9, the remainder value here is 2. And 10. See here, for 10, the remainder value is 3. And this is 5 plus 6. This is 11 when divided by 7. See here, the remainder value is 4. Write the remainder. And next one, 6 plus 0 is 6. And 6 plus 1 is 7. 7 when divided by 7, the remainder is 0. 8, the remainder is 1. 9, the remainder is 2. And next one, 10, the remainder is 3. And next one, this is 11, the remainder is 4. And next one, this is 12. So for 12, if you divide with 7, so what is the remainder here? 5. So this value is 5. So this is how we have to do. We have to add up these two, and again we have to divide with 7. The remainder is the value. So this is how we have to fill the addition modulo 7. So if you observe all these, all the elements are the elements from the set G. Set G are nothing but 0, 1, 2, 3, 4, 5, 6. So here also there is no element which is less than 0 and after greater than 6. All the elements are 0, 1, 2, 3, 4, 5, 6. And therefore, according to the closure law, all the entries in the composition table are the elements of G, and therefore G is closed under addition modulo 7. And next one, coming to closure law is satisfied. And next, coming to associative law, the elements of G are integers, and we know that the set of integers is an associative law, and therefore G is satisfies associative law with respect to addition modulo 7. And next one, coming to identity law. So from the composition table, we see that 0 is the identity element. So for addition, 0 will be the identity element. And next one, we need this one, inverse law. For the inverse law, from the composition table, this is the composition table. So wherever you find the identity element is 0. See here, for element 0, the inverse will be 0. See here, for 1, go to the identity element. See here, the top element is the inverse of 1, 6. For 2, go to the identity element, and this top element is the inverse. So the 2 inverse is 7. Sorry, the 2 inverse is 5. So next one, 3, go to the identity element, and this top element is 4 is the inverse element of 3. And next one, 4, go to the identity element, 0, and this top element is the inverse element, 5. Go to the identity element, and the 2 is the inverse of 5. And the next one, 6. For 6, go to the identity element, and the top element here is 1. And therefore, 6 inverse is 1. So among all these 0, 1, 2, 3, 4, 5, 6, each and every element is having the inverse element. So each element has an inverse element, and therefore G satisfies the inverse law. And according to the commutative law, as you know that from the composition table, we see that, see here from the composition table, if you observe, every row equals every column. See here 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. If you observe this one, 2, 3, 4, 5, 6, 0. This is 2, 3, 4, 5, 6, 0. And next one 3, 4, 5, 6, 0, 3, 4, 5, 6, 0, 1. And next one, if you observe this one, this is a 6012, this is 6012, this is 123 123 3434. So every row equals every column, and therefore it is nothing but the commutative law. From the composition table, we see that the ith row is same as the jth column, where I is equal to 1 2 3 4 5 6 7, and therefore G is commutative. From the composition table, see here all the entries in the table are the elements of G, therefore it is closed. Associative, all the elements are integers, satisfies associative law. So as you know that for the addition, 0 will be the identity element. So here from the composition table, each and every element has an inverse element, and commutative law, every row equals every column here, and therefore this is commutative law. And clearly we say that G plus 7, that is G addition modulo 7, is an abelian group. Clear? And the next question here is, the second question here is, now we have to show that the set is given. So which set is given? G is the set given as 0 1 2 3 4, sorry, there is no 0, 1 2 3 4 5 6, and we have to show that it is an abelian group with respect to the binary operator multiplication modulo 7. So here from the composition table, so we have to fill all the table entries. So here according to the table entries, what is multiplication modulo 7? So when A and B are multiplied, the remainder when A and B are multiplied by the modulo 7. So now 1 into 1 is 1, 1 divided by 7 is again 1. So 1 into 2 is 2, 1 into 3 is 3. So 1 into 4 is again 4. And next 1 into 5 is 5, 1 into 6 is 6. Clear? And next one, 2 ones are 2, 2 twos are 4, 2 threes are 6. Next one, 2 fours are 8. So after multiplication, the remainder, see here the remainder, when A into B is multiplied by 7, the remainder here is 1. 2 fives are, sorry, next one, 2 fives are 10. 10 when divided by 7, so here the remainder value is 3. And next one, 2 sixes, this is 12. And when divided by 7, this is 7 ones are 7, so the remainder here is 5. Clear? And next one, 3 ones are 3, 3 twos are 6, 3 threes are 9. If you take 9 and divide with 7, see here the remainder value is 2. 2 fours are, this value is 12, the remainder value is 5 here. This is 15. So 3 5s are 15 when divided by 7 for 2 times, the remainder here is 1. And next one, 18. So here 18, if you divide with 7, here 14, and the remainder value is 4 here. Clear? And next one, 4 ones are 4, and next one, 4 twos are 8. 8 when divided by 7, the remainder value is 1. This is 12. 12 when divided by 7, the remainder value is 5. This is 4 fours are 16. So here 16 when divided by 7, 2s are 14, the value here is 2. This is 4 5s are 20. 4 5s are 20, and here this value is 14, the value here is 6. And next one, this is 24. 24 when divided by 7, 3s are, this is 21, the value here is 3. The value here is 3. This is 5 ones are 5, 5 twos are 10. For 10, the remainder value here is 3. And 5 threes are 15. 15, the remainder value is 1. And 5 fours are 20. 20, the remainder value is 6. And next 5 5s are 25. For 25, if you divide with 7, that is 3s are 21, the value here is 4. And this is 30. 30 when divided by 7, see here 4s are 28, the remainder value is 2. And next one, this value is 6, this value is 12, the remainder value here is 5. And next one, this is 18, 18 here is 4, remainder. And next one, this is 24, so 24, the remainder value here is 3. And this is 30, so for 30, the remainder value here is 2, this is 2. And this is 36. So 7 5s are 35, the remainder value is 1. So now we have to multiply and you have to divide with 7, and therefore the remainder value will be the entry answer. So here, if you observe this one, so what is from the set G? 1, 2, 3, 4, 5, 6. If you observe, all the entries in the table are the elements from the set G. And this is nothing but, if you take one element 2 from G and 3 from G, and therefore 2, 3 is 6 is also from G. And therefore, according to the closure law, all the entries in the composition table are the entries of G. And therefore, G is closed under multiplication modulo 7. And next one, coming to the associative law, the elements of G are integers. And we know that the integer satisfies associative law, and therefore G is associative with respect to multiplication modulo 7. And coming to the identity law, as you know that for addition 0 is the identity element, and for multiplication 1 is the identity element. Therefore G satisfies the identity law. And next one, coming to the inverse law, as you know that all the entries in the table are filled, and now 1 is an identity element. So for each and every element we have to check this one, inverse element. So we have to go with the identity element. For 1, the top element here is 1, and therefore the inverse of 1 is 1. For 2, if you go with the identity element, the top element is 4, and therefore the inverse of 2 is 4. And for 3, we have to go with the identity element, and here the top element is 5, and therefore the inverse of 3 is 5. For 4, if you go to the identity element, the inverse element is 2, and therefore 4 inverse is equal to 2. And for 5, if you go to the identity element, the top element here is 3, and therefore 5 inverse is equal to 3. And for 6, if you go to the identity element, the top element here is 6, and the inverse of 6 is equal to 6. And therefore every element of G has an inverse element, and therefore G satisfies the inverse law. And next, coming to the commutative law, if you observe from the composition table, each row is equals each column. See here, 1, 2, 3, 4, 5, 6. This is also 1, 2, 3, 4, 5, 6. This is A into B is equal to here B into A. And next one, this is 4, 6, 1, 3, 5. This is 4, 6, 1, 3, 5. This is 2, 5, 1, 4. This is 2, 5, 1, 4. And next, if you observe this 2, 6, 3. This is also 2, 6, 3. This is 4, 2, and this is 4, 2. If you observe from the composition table, we see that the elements of ith row are same as the elements of the jth column. Therefore, we say that G is commutative with respect to multiplication modulo 7. So from all these, the first thing here is the closure property. This one is the closure law, this one is the associative law, this one is the identity law, and this one is the inverse, and this one is the commutative law. If all the properties holds, that is closure, associativity, identity, inverse, and commutative law, we say that G is an abelian group with respect to multiplication modulo 7. So that is how we have to solve. I have told you in this video about addition modulo 7, when the remainder when two elements are added and again it is divided by 7 is nothing but the addition modulo 7. What about this multiplication modulo 7? The remainder when two elements are multiplied and again divided by 7. So addition modulo m, that will be the multiplication modulo m. So here both the definitions I have taught you, and how to enter the entries in the composition table also I have taught you, and I have explained all the 5 properties, that is closure, associativity, identity, inverse, and commutative law. And finally I have proved that it is an abelian group, and this is how you have to solve, and whatever the problem is given, so this is the procedure, this is the process. And if you really like, you know what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel, and stay connected for more theorems and problem solutions. It will be very helpful. Thank you so much.